Chapter 1. Now the next topic is electrostatic potential energy of a point charge but of collection of charges. We have already derived an equation for electrostatic potential energy of a point charge. So you will first find out what is potential, and then you need to find out what is work done, and then for not only for one charge, I need to find out for all the three charges. That is how it is done. So V is equal to 1 by 4 pi epsilon naught Q1 by R. This is for the point charge. But I need to find out for an unit positive charge from infinity to the point. So W, that is between Q1 and Q2. Between this, what should be the work done? So work done is given by Q2 into V. I just substitute Q2 in this equation. Then I get this as the potential energy. This is between Q1 and Q2. But for a system of charges, for collection of point charge, this U will be equal to, where 1 by 4 pi epsilon naught is taken as common and all the other things are added. It's a sum of other potentials. View the video, children. You can clearly even more understand what is done or how the potential is calculated for a whole system.
So please do watch it and enjoy learning physics.
Of system of charges. The electrostatic potential energy of a system of charges is defined as the work done to bring the charges of the system from infinity to their respective positions. A. For system of two-point charges, consider two-point charges Q1 and Q2 at points A and B, whose positions from fixed point O is given by position vectors R1 bar and R2 bar. In composing the above system, let Q1 be brought from infinity to A, for which no work is required to be done as it is not opposed by any force. Now the work done in bringing Q2 from infinity to B is the electric field of charge Q1 is W is equal to potential due to Q1 at B into Q2 is equal to 1 by 4 pi epsilon naught into Q1 by AB into Q2 is equal to 1 by 4 pi epsilon naught Q1 Q2 by R2 bar minus R1 bar is equal to 1 by 4 pi epsilon naught dot Q1 Q2 by R1 2. This work done will be stored in the form of PE of system of two-point charges. Therefore, U is equal to 1 by 4 pi epsilon naught dot Q1 Q2 by R1 to B. For system of three-point charges, consider point charges Q1, Q2, Q3 at A, B, C. Work done to bring Q1 from infinity to A is 0, as discussed earlier. Work done to bring Q2 from infinity to point B is W1 2 is equal to 1 by 4 pi epsilon naught dot Q1 Q2 by R1 2. Work done to bring Q3 from infinity to C in the electric fields of Q1 and Q2 is W1 3 is equal to potential at C due to Q1 and Q2 into Q3 is equal to 1 by 4 pi epsilon naught of Q1 by R1 3 plus Q2 by R2 3 of Q3. Therefore, total work done to form the system, which is stored in the form of PE, is U is equal to W12 plus W13. U is equal to 1 by 4 pi epsilon naught of Q1 Q2 by R12 plus Q2 Q3 by R2 3 plus Q3 Q1 by R3 1. The above expression of U is independent of the manner in which configuration is assembled, indicating the conservation nature of electric field. Thus, U is state dependent and path independent.